probabilistic EOQ model. This model allows storage of demand. The policy calls for ordering the quantity Y whenever the inventory drops to level R. Quantity Y and whenever the inventory drops to level R. As in the deterministic case, the reorder level R is a function of the lead time between placing and receiving an order. Reorder level R is a function in a lead time between placing and receiving an order. The optimal value of Y and R are determined by minimizing the expected cost per unit time. Next, the optimal value of Y is expected cost per unit time. That includes sum of the setup cost, holding cost and shortage cost. The model has three assumptions. First one, unfilled demand during a lead time backlog. Second one, no more than one outstanding order allowed. Third one, the distribution of demand during lead time remains stationary with time. Next, to develop the total cost function per time, let f of x is equal to PDF of demand x during lead time, d is equal to expected demand per unit time, h is equal to holding cost per inventory unit per unit time, p is equal to shortage cost per inventory unit, k is equal to setup cost per order. Based on these definitions, the elements of the cost function are now determined. First, setup cost. The approximate number of order per unit time is d by y, so that the setup cost per unit time is kd by y. Setup cost is equal to kd by y. Expected holding cost. The average inventory is I is equal to y plus e of r minus x plus e of r minus x by 2. Simplifying this, y plus r minus e of x plus r minus e of x, which is equal to y by 2 plus r minus e of x. The expected holding cost per unit time thus equals hi. Holding cost is equal to h into I is equal to y by 2 minus r, y by 2 plus r minus e of x. The symbol is based on the average of the beginning and ending expected inventories of a circle u plus e into r minus x and e into r minus x respectively. As an approximation, the expression ignores the cost where r minus e of x may be negative. Next, third one, the expected shortage cost. Shortage occurs when the expected shortage quantity per cycle is S is equal to integral r to infinity x minus r f of x dx. Because P is assumed to be proportion to the shortage quantity only. P is a shortage quantity only. The expected shortage cost per cycle is Ps, and based on d by y cycle per unit time, the shortage cost per unit time is P into ds by y. Therefore, the shortage cost is equal to P into ds by y. The resulting total cost function per unit time is total cost is equal to sum of the three costs, setup cost, holding cost and shortage cost. T containing u of y comma r is equal to d k by y plus h of y by 2 plus r minus e of x plus p d by y into integral r to infinity x minus r f of x dx. The solution for optimal y star and r star are determined from next, the optimal y star and r star that is determined from this equation. Y star கண்டுபிடிக்க with respect to y க்கு differentiate பண்ணனும், r star கண்டுபிடிக்க with respect to r க்கு differentiate பண்ணனும். with respect to y க்கு differentiate பண்ணும்போது minus dk by y square plus h by 2 minus p ds by y square is equal to 0. அதுபோல் with respect to r க்கு differentiate பண்ணும்போது we get h minus p d by y into integral r to infinity f of h dx is equal to 0. Thus we get y star is equal to, from this equation we get y star is equal to root of 2d into k plus ps by h. This is equation number 1. Simplifying this equation we get integral r star to infinity f of h dx is equal to h y star by pd. The equation number 2. Because y star and r star cannot be determined in closed forms from 1 and 2, a numeric algorithm developed by Handley, algorithm is developed by Handley is used to find the solutions. The algorithm is proved to converge in a finite number of iterations provided a feasible solution exists. Feasible solution கிட்டத்தட்ட நம்ம iteration போயிட்டே இருக்கு. For r is equal to 0, the last two equations respectively yield. When r க்கு value 0 போடும்போது last 1 and 2 equations yields y cap is equal to root of 2d into k plus p into e of h by h, and y tilde is equal to pd by h. If y tilde is greater than or equal to y cap, unique optimal values of y and r exist. Y tilde is greater than or equal to y cap irundha, the optimal values of y and r exist. The solution procedure recognizes that the smallest value of y star is root of 2d to kd by h, which is achieved when s equal to 0. When s equal to 0 போடும்போது y star உள்ள the smallest value கிட்டும், அது என்னன்னு சொன்னா root of 2 kd by h. The steps of the algorithm are next the algorithm step 0, use the initial solution u is equal to u star minus root of 2 kd, and let r naught is equal to 0, set I is equal to 1 and go to step I. First வந்து initial solution use பண்ணனும். u is equal to u star minus root of 2 kd, and let first r naught value 0 போடணும், set I equal to 1 போடணும். அடுத்து step I, use y, next go to step I, use yi to determine ri from equation if ri is approximately equal to ri minus 1. ri minus 1 value equal to வரும்போது stop பண்ணணும். The optimal solution is y star is equal to yi and r star is equal to ri. Otherwise அல்லனா use ri in equation 1 ல ri use பண்ணணும் to compute yi. Set I is equal to I plus 1 போடணும் and repeat the step repeat பண்ணிட்டே இருக்கணும். Optimal solution yi ri is equal to ri minus 1 வரது வரை equal to வரது வரை step I repeat பண்ணிட்டே இருக்கணும். Next one example, electro uses resin in its manufacturing process at the rate of 1000 gallons per month. It cost electro rupees 100 to place an order for a new shipment. The holding per gallon per month is rupees 2 and the shortage cost per gallon is rupees 10. Historic data show that demand during lead time is uniform over the range 0,100 gallons. Determine the optimal ordering policy for electro. Solution, using the symbol of the model we have D is equal to தந்திரிக்க கொஸ்டின்ல இருந்து டேட்டாஸ் கலெக்ட் பண்ண D is equal to first demand expected D is equal to 1000 gallons per month. K is equal to setup cost K is equal to 100 holding cost H is equal to 2 per month. P is equal to shortage cost P is equal to 10 per gallon. F of x is equal to PDF of the demand x f of x is equal to 1 by 100 comma 0 less than or equal to x less than or equal to 100. The next E of x is equal to 0 plus 100 by 2 is equal to 50 gallons. First we need to check whether the problem has a feasible solution. First feasible solution irukanu nama check pananum. We have y cap is equal to root of 2dk plus p e of x by h. நமக்கு தெரிஞ்ச வேல்யூஸ் எல்லாம் அதில் சப்ஸ்டியூட் பண்ணணும். இஸ் ஈக்குவல் டு ரூட் ஆஃப் 2 இன்ட்டு டி 1000 இன்ட்டு கே 100 ப்ளஸ் பி 10 இன்ட்டு இ ஆஃப் எக்ஸ் நம்ம கண்டுபிடிச்சி வச்சிருக்கு 50 gallons 50 by 2 இஸ் ஈக்குவல் டு 2 கேன்சல் which is equal to root of 1000 into 100 plus 500 which is equal to root of 1000 into 100 plus 500 600 which is simplify panama 774.6 gallons. Also we have y tilde is equal to pd by h which is equal to P 10 into D 1000 by 2 is equal to 5000 gallons. Here y tilde is greater than or equal to y cap. Unique solution exists for y star and r star. நம்ம நேரத்தை பார்த்தோம். If y tilde is greater than or equal to y cap, the unique optimal solution y and r exist. அதே மாதிரி இங்க here y tilde is greater than or equal to y cap, the unique solution exists for y star and r star. Now we compute the value of s. இப்போ நம்ம compute the value of s. We have s is equal to s formula நேரமே படித்தோம். Integral r to infinity x minus r f of x dx which is equal to integral r to 100 in x minus r into 1 f of x 1 by 100 dx which is equal to 1 by 100 வெளியில் எடுக்கணும். Integral r to 100 x minus r dx which is equal to 1 by 100 into x square by 2 integrate பண்ணோம் x square by 2 minus rx into r to 100 which is equal to 1 by 100 into 100 square x இருக்க இடத்துல first 100 next r இது போட்டு simplify பண்ணா 100 square by 2 minus r into 100 minus r square by 2 minus r square which is equal to 1 by 100 into simplify பண்ணுமா 5000 minus 100 r minus of minus r square by 2 இது LCM எடுக்கும். Therefore s is equal to r square by 200 minus r plus 15 கிட்ட. This is equation number 1. Also we have yi is equal to root of 2d into k plus ps by h. Equation number 1 first நேரமே பார்த்தோம். அதுபடி also we have yi is equal to root of 2d k plus ps by h which is equal to root of 2 into d demand d 1000 into 100 plus 10 s p के value 10 s के value நமக்கு தெரியாது. Therefore s by 2 which is equal to root of 1000 into 100 plus 10 s. Therefore yi is equal to root of 1000 plus 1000 yes this value given. This is equation number a. Also integral ri to infinity f of x dx is equal to ஹைச் ஒய்ஐ பை பிடி நேரமே பார்த்த இதில் இக்குவேஷன் நம்பர் 2ன்னு போட்டிருப்போம், நோட் பண்ணியிருப்போம். அந்த இக்குவேஷன் தான் இது. ஆல்சோ இன்டெக்ரல் ஆர்ஐ டு இன்ஃபினிட்டி எஃப் ஆஃப் எக்ஸ் டிஎக்ஸ் இஸ் ஈக்குவல் டு ஹைச் ஒய்ஐ பை பிடி, தட் இஸ் இன்டெக்ரல் ஆர்ஐ டு 100 f of x value 1 by 100 dx is equal to h 2 yi by p value 10 into d value 1000, which implies 1 by 100 into 1 by 100 வெளியில் எடுக்கணும். அப்போ 1 by 100 into ri to 100 dx is equal to yi by 5000. X into ri to 100 is equal to yi by 50. Therefore, substitute பண்ணும்போது 100 minus ri is equal to yi by 50. Therefore, ri is equal to 100 இந்த சைடு போகும்போது 100 minus, this is simplify பண்ணும்போது ri is equal to 100 minus yi by 50. This take us equation number 2. Now we use equation 192 to determine the solution. 192 வச்சு இனி நம்ம solution கண்டுபிடிச்சோன்னா first iteration 1, y1 is equal to s க்கு வேல்யூ 0 போடணும். அதுதான் சின்ன சொல்யூஷன், நம்ம ஏற்கனவே பார்த்தோம். when s equal to 0 போடும்போது yக்கு சின்ன வேல்யூ கிட்டும். therefore y is equal to y1 is equal to root of 2kd by h. equation number yi equal to 2k, yi is equal to இங்கே இருக்கு equation yi is equal to y star is equal to root of 2d into k plus s by h. இந்த equation number 1 லையாக்கும் y1 is s க்கு வேல்யூ 0 போடும்போது y1 is equal to root of 2kd by h, which is equal to root of 2 into k value 100 into d value 1000 by 2, which is simplify பண்ணும்போது இந்த வேல்யூ கிட்ட இதுக்கு ரூட் எடுக்கும்போது which is equal to 316.2 gallons. Next equation 2. equation 2 இந்த equation 2 இருக்கு. The equation 2 ri is equal to 100 minus yi by 50. First I இருக்க இடத்துல 1 போடணும். அப்போ r1 is equal to 100 minus y1 by 50, which is equal to 100 minus y1 value there இருக்கு 316.2 by 50, which is equal to 100 minus simplify பண்ணும்போது 6.2324, which is equal to 93.68 gallons. Next iteration 2. Now s is equal to r1 square by 200 minus r1 plus 50. This is equation number 1. Equation 1, which implies s is equal to, first நம்ம s க்கு வேல்யூ 0 எடுத்தோம். அடுத்து s is equal to r1 square by 200 minus r1 plus 50. இதில் r1 ஓட வேல்யூ சப்ஸ்டியூட் பண்ணணும். which is போன இட்ரேஷனில் r1 க்கு வேல்யூ இருக்குது, அதை சப்ஸ்டியூட் பண்ணணும். which is equal to 93.68 the whole square by 200 minus 93.68 plus 50. simplify பண்ணணும். simplify பண்ணும்போது we get 0.199712 gallons. Next now we get r1 value, s value. Now we get s value. Next equation number a, which implies a எடுக்கணும். y2 is equal to அதில் y I இருக்க இடத்துல 2 போடணும். y2 is equal to root of equation 2a equation a இதாக இருக்குது. yi is equal to root of, இதில் s ஓட வேல்யூ நம்ம இப்போ கண்டுபிடிச்சோம் iteration 2ல ஃபஸ்ட்டு s is equal to 0.199712 gallons. இதை சப்ஸ்டியூட் பண்ணணும். சப்ஸ்டியூட் பண்ணி சிம்பிளிஃபை பண்ணணும். 319.37 gallons. Next y2 equation 2 which implies y in the y2 value equation 2 ல போட்டு r2 value கண்டுபிடிக்கணும். r2 is equal to 100 minus y2 by 50 is equal to 100 minus this value y2 value substitute பண்ணி simplify பண்ணணும். 93.61 gallons. Next iteration 3, s is equal to r2 square by 200 minus r2 plus 50. We substitute r2 value from iteration 2 substitute பண்ணி s ஓட value substitute பண்ணி simplify பண்ணாம s ஓட value s is equal to 0.204 gallons கிடைக்கும். Therefore அந்த s ஓட value y3 ல போடணும். y3 ல போடும்போது y ல போடணும். அப்போ y3 is equal to s ஓட வேல்யூ சப்ஸ்டியூட் பண்ணி சிம்பிளிஃபை பண்ணும்போது y3 is equal to 319.44 gallons கிடைக்கும். Therefore now we see y3 319.44 gallons, அது மாதிரி y2 319.37 gallons, ரெண்டும் அப்ராக்சிமேட்டாக ஈக்குவல். நெக்ஸ்ட் r3 இந்த y3 ஓட வேல்யூ சப்ஸ்டியூட் பண்ணி r3 ஓட வேல்யூ கண்டுபிடிக்கணும். r3 is equal to 100 minus y3 by 50. y3 ஓட வேல்யூ சப்ஸ்டியூட் பண்ணும்போது r3 is equal to 93.61 gallons கிடைக்கும். அதே மாதிரி இந்த r3 r2 ஈக்குவலாக இருக்குது. அப்போ இதோட ஸ்டாப் பண்ணணும். பிகாஸ் r2 and r3 are approximately equal. We approximate optimal solution is approximately optimal solution எடுக்கும். r star is equal to 93.61 gallons and y star is equal to 319.44 gallons. Thus the optimal inventory policy calls for ordering approximately 314 gallons whenever the inventory level drops to 94 gallons.